Hello, everybody. I want to say hello to all of you who are who come and visit this webinar. Timo Kytölä from Finland, Hack Instruments, will present today this product line. And Timo, you can start.
Yes, thank you, Janes. Nice to be here in this webinar. Actually, this is my first webinar ever. So it will be exciting to host this event. So Janes, we are here together because HK Instruments and Janes' company Arbor Vita are working together in Balkan region, and Arbor Vita is working as our partner, our distributor to present HK brand and the products in your region. So let's start about the slideshow about HK Instruments, who we are and what we do. So just a moment, I will share the screen. I put on the slideshow. Okay, so let's begin. So I'm Timo from HK Instruments, and I have been working here for almost 10 years now. And HK Instruments was founded roughly over 30 years ago by a man, Heikki Kalliomäki, which you can see on the picture. And from the beginning, we have been located in Muurame, Finland, and actually Muurame is also my birth city. So I know the place very well. And we have all the operation nowadays still in Muurame. We have product development, sales, production, all the different functions of the company here in one place, which means that we can act very fast and rapidly in different things. And the product line which we produce is the measuring device for the HVAC and the building automation. That's our core know-how. That's what we know how to do. And since the beginning, we have been always growing fast, but still steadily. And also, we have been always global company because we have quite narrowed down product portfolio, which means that we have to go abroad and find partners like Arbor Vita to present our products in their own market areas. So our global presence is mainly in Europe and in Scandinavia, but we are also famous and strong in Americas and Asia. And our core values and basically how we operate is based on family, friendship, and the basic needs of people. And by saying family, I don't mean just the owner, the brothers who own the company, but also the employees and basically all the shareholders we work with, like partners, customers, and suppliers. And for them, we want to set this kind of friendship atmosphere between daily operations. And then how do we stand out from the competition? We believe in long-term partnership, which is based on trust and loyalty. We believe by working like that, the best output will come in the long run. And what comes to the products themselves, when we are designing the products, we are always thinking about the guy who is installing those on the field. So that's why when we are doing product development, we want to make the products easy to use, to be user-friendly, and easy commissioning. And we want to provide also this friendly but still very professional customer service. And we have very flexible production, and that comes out as a fast and on-time deliveries. And we have been also making this kind of product customization for many OEMs. We have many white label customers, and we have used to that. And actually we enjoy this kind of a challenge to take from some OEM who ask us to provide some customized solution. Then we can really show the art of the engineering to find out the best solution. So basically what we want to do is deliver this best customer experience, on the HVAC sector. Then we can take a look at the applications. But before this, I want to show you this kind of very new European Commission new strategy for the renovating the building stock in the Europe. This was done maybe 1.5 months ago, this new strategy, because the fact is that the EU has been committed to reduce the emissions with over half by the year 2030. And if you look at the existing buildings and how much do they account for the energy usage of the total in Europe, it's 40%, and greenhouse gas 36%. So it's a fact that we have to do something about the old buildings to renovate them to be more energy efficient. And next year, Commission will be revising this energy efficiency directive for the buildings, which they launched some years ago, but I think now they have to do some more drastic measures. And I believe that the outcome in our field will be that the increasing the level of automation for HVAC systems, the process will be optimized to maximize the energy efficient operations, but at the same time, we want to make sure that the indoor air quality is good for the occupant, good and safety. So let's take a look at the air handling unit control system. This is the very basic application, maybe the most common for our products, because we can measure all the necessary parameters which has impact to the control system. So for example, if we are speaking about the pressure and the differential pressure, that's our core know-how. So basically what you need to measure from this unit with the differential pressure is the fans and the filters. The fans you can measure with the differential pressure, and with this kind of calculation you can get the airflow rates directly based on the differential pressure. And the filter clocking you can sense with the pressure difference. And also this control strategy called duct static pressure control. You need to have a pressure transducer to maintain the designed static pressure. And then we have other parameters we can measure, like temperature, which is very basic. We have passive temperature sensors for duct and or cable, and then we have new ones now that are coming up. It's for liquid, so we can also measure liquid, for example heating coils from the unit. And then also this indoor air quality parameters, for example CO2 or humidity from the duct. The traditional solution was the signals were sent with the analog outputs, but nowadays the field buses have been becoming more popular, especially for the OEMs. And also we have solution for this. We are supporting a Modbus solution with our devices. And why is it good for the OEM? The reason is that in our Modbus devices, we have been integrating this kind of I/O points also to these devices, which means that we can contact, for example, 2 passive temperature sensors to our DPT dual mode or DPT I/O mode. And with dual mode, as the name says, it has 2 inbuilt pressure sensors. So you can get, for example, the fan pressure, and by that you can also get the airflow rate. But with the same device, you can get also differential pressure, for example, over the filter, and also 2 temperature sensors in addition. So basically what you can do is get 4 measurements to the bus by using 1 device. So it means that it reduces the amount of cabling need on the factory, which makes the production process for the air handling unit producers more faster, more lean. Yeah. Then this application roof extraction unit is maybe more to Scandinavian, because we use a lot of these roof extraction units for this kind of blockhouse with different apartments. So basically from these apartments, we can measure indoor air quality. For example, there can be a humidity sensor on the laundry room, and when it starts to sense increased level of humidity, with this model which has a relay inside, you can connect it to our DPT control mode. The control comes from the control world. So in addition, just to measure the duct static pressure or the airflow rate from the extraction unit fan, it can also control it, as long as the control device is EasyFan, which can accept 0 to 10 voltage input. So what you can do is you can, if you're using EasyFan, you can measure and control with same unit, so you don't have to don't need to have a separate VFD, which saves the costs. And by connecting the relay to DPT control, you can switch between 2 different set points. So for example, you can boost the fan when the humidity levels are too high, that goes over the threshold value. And also you can control based on CO2 from the rooms or VOC now for this new upcoming Zero product. And demand controlled ventilation is very popular nowadays. We are talking about these VAV systems, which you can alter the flow rates based on occupancy level in different zones or rooms. So typically for demand controlled ventilation, we use CO2 as the variable to detect how many people there are inside the rooms or how bad or good the air is. So this is a very good strategy, this VAV system for keeping an eye on the energy efficiency, because you don't need to over ventilate the room, but just then when the people are inside the room, you can rise up the flow rates to ensure good and healthy atmosphere there. Then we have also solutions for the, especially in this picture, we can see there is this district heating unit, which is heating this building based on temperature. So the system is working by maintaining inside room temperature, which we can measure with the PTE room, and also the outdoor temperature impacts how much do we need to heat the building. And then in Finland we have this new way to monitor how well the building will be, because we want to make sure that the building pressure, inside pressure compared to outside pressure, is almost zero. We typically want to set the differential pressure between the building envelope slightly under pressure, but we never want to go over pressure, because otherwise, here in Finland, for example, we have very moist air that if we push the moisture and the bacteria to the walls, it can cause molding over time. So that's why we have this DPT Prima that can be connected to this SPP, which is static pressure port. So we measure the differential pressure over the building envelope and trying to maintain almost zero differential pressure, maybe -2 or 3 Pascal. And this SPP is blocking the wind gust effect to the measurement by filtering it. That's the purpose. And the last, we have the clean room application. We have been working in this sector for many years because our device is well suitable for there. So basically, the typical measurement that we do for clean room are humidity, temperature, and small differential pressure. So what comes to pressure, we typically set so that we need to know the pressure differences between the corridor and the clean rooms and maintain those, let's say ±10, yeah. And then humidity and temperature will be also be measured from the clean room, and based on what you're doing inside the clean room, we can control those. And then we have this DPG for this laminar flow cabinets, and also this a bit special product which is very convenient for this application is the DPI, because it's basically normal differential pressure transmitter, but in addition it has this relay outputs. So you can have 2 different relays that you can set up separately and put different threshold values. And if you go over or down, you can choose either way you want to have it. The switching direction, you can set some alarms. For example, if you want to maintain some pressure difference, but then you start to lose it, you can make alarm by control the relay to some beacon lights or buzzers, whatever is the best way to indicate that you need to do something about it now. So then we can go closer to the individual products. So first we go through this differential pressure transmitters we have. So first we have this DPTR8, which is the most popular and versatile DP transmitter we have in our portfolio. And the basic applications are the filter status on the unit and also the duct static pressure monitoring on the air handling unit. And also you can use it for the clean rooms for over or under pressure monitoring. And what we have in this is 8 different measuring ranges. So basically you can find most commonly used ranges from same unit, so you don't have to have big inventory for different applications. Instead, you can use basically 1 or 2 different models. And this has both milliamp and voltage output that you can choose with the jumper settings. And the sensor technology we are using is digital MEMS sensor. And we have seen that the 0-point drifting, which used to be typical for this kind of sensor technology, it doesn't exist that much anymore. We are talking about maybe ±2 Pascal drifting over 1 year, but not bigger than that. And also one good benefit is that it's not affected by vertical position because the sensor element itself is so small, so the gravity doesn't have impact to that. And we have optional feature on this one, the auto zero option. And it really means that the zeroing of the device has been done automatically in every 10 minutes. So basically, that's the only thing to zero the device you need to do as a maintenance task. So when the auto zero is doing that automatically, you don't have to do it anymore. So it's making the device basically maintenance free. And also in the same time, it's increasing the accuracy a bit. So if you are using it clean rooms, for example, that's highly recommended to be used. And then we have this special model, because we come from Finland, that can go down to -40. We call it Lapland model. There is a small heating element inside the housing to heat up the electronic so that it can withstand the operation down to -40. Then this is basically almost the same as the one I showed before, the DPTR8, but this is a new model which we have updated the sensor to be more precise, to focus on the clean room applications and all the other applications which require higher accuracy, such as the building envelope measurement. You can see the accuracy rate there. It's 0.4 plus minus 0.4 pressure, and that's from the reading, not from the full scale. So basically, I have calculated that the accuracy is about 0.5 Pascal within the range of ±50 Pascal. So that should be adequate to be used in the clean room applications. And it has also milliamp and voltage output. And this MEMS sensor that is not affected by vertical position. And typically clean room DP transmitter are requested not only with the zeroing possibility, but also with the span point calibration. So you can do this kind of field calibration by adjusting the span with this kind of potentiometer. Then we have this DPI, the pressure switch, and the applications are, as said before, the clean rooms by controlling some alarms or beacon lights. And then I read an article from Rehva just a moment ago that they are suggesting this kind of instrument for the patient rooms for COVID patients that has been isolated. And there was mentioned that they should maintain at least 5 Pascal under pressure in the isolation room. And if there comes some leakage or something happens in the ventilation, they should have an alarm from that. So to make sure that the airborne particles from the COVID doesn't spread around. And also one application could be the boiler pressure monitoring, so that the flue gas will be controlled in the right direction. And what you have there, in addition to 0 to 10 voltage message output, you have this up to 2 separately configurable relays. And you can use those up to 6 amperes, so you can basically control device without any contactor there. And you can freely configure the switching point with 1 Pascal resolution for both relays, and you can choose the direction, if it's open on rise or fall in pressure. And also you can set the hysteresis. So basically you can do very precise settings for the relays. And we have 2 models from there, and each model has 4 pressure ranges inside. And with this one you can also have the device with the auto zero and the span. Then we have these airflow transmitters. We call it DPT flow. It's like an evolution from the standard differential pressure transmitter. And it can convert the differential pressure directly to the airflow. And you can have the airflow rates directly to your PLC as an analog signal, or also with the Modbus is possible. And you can connect it also for induct airflow measurements, where you can use, for example, some kind of pitot tube, as we have also this own averaging pitot tube called Floxact. And the competitive edges we have there is that you can use it also as a standard differential pressure transmitter or the airflow. So it's kind of versatile if you are if your applications are divided sometimes to airflow and sometimes to just the pressure, you can just stock this one in yourself. And you can also freely configure the outputs with the jumpers for milliamp or voltage. And we have defined this kind of K value or flow formulas for different fan producers, such as Flechtwoods, we have Rosenberg, Nicotra, EPM pubs, and so on. So basically you need to know only which is the producer of the fan and what is the K factor. And it's like a plug and play, so very easy and fast for the commissioning. And you can have this one also with the automatic 0-point calibration. And then we have another solution for the air velocity or the flow measurement in the duct. So basically this slide is showcasing both principles we can use. As mentioned in the earlier slide, something about the Floxact, which you can see in the picture, it's this kind of averaging pitot tube. And you can use it for the induct flow measurement. It's very easy to install because you just need to screw it on the duct, and you can have basically those for all the different sizes, standard sizes, but also in addition to custom made. That's not the problem. So it's based on this pitot tube principle that you just connect the pressure transmitter for the high side and the low side, and the result will be the dynamic pressure, which there is a formula that corresponds to the airflow. The other way to do this induct airflow or velocity measurement is our air velocity transmitter AVT, and that is based on the hot wire technology. It's very easy to install and configure, and you can have it also with this adjustable relay output. So then you can use it as an airflow switch. But my recommendation is always to choose this multiple point probe, which is the flow shaft, because you can see on the picture the flow profile. Even if the airflow is laminar, there is still variation for the air velocity. And if you're using 1 point measurement, you just get only the 1 point velocity. But the multiple point senses these multiple velocities, and then it's averaging those. So the result will be more accurate. Then we will take a look at the latest development for the DPT product line. So the DPT control or the DPT control mod. It's basically similar user interface that was in the DPT flow, the airflow transmitter, but in addition to that we can measure the airflow or the differential pressure, we can also control it. So this has 0 to 10 voltage control output that you can connect, for example, to air handling unit EC fan or fan walls. And or also you can use it to exhaust fans based on constant static pressure or air volume flow. Or one special application is this negative pressure units. If you want to maintain a constant pressure between 2 different rooms, and you can use this NPU to suck the air, you can control the pressurizing unit by using this device. So this unit has inbuilt PID regulation, so you can determine the P term, the I term, and the D term. As a default, it has quite good terms, so basically it should be quite close to plug and play, but typically the PID terms are depending on the application. So you need to play around a bit to find the right parameters. And then we have this DPT control also in the Modbus version, and the Modbus version has some extras because you can make this kind of remote set point changings nowadays with the control mod. So it has inputs, for example, for a relay switch. So you can bring the relay information to the input, and you can choose between the low and the high set points. And you can get the Modbus to connect it to the BMS. So it means that you can change the parameters and the set points easily from the bus. So you don't have to go there as a person near to this device to make adjustment. So it's very easy to use device. Then we can talk a bit more about the Modbus transmitters. For the pressure, we have this DPT mod and DPT IO mod. The IO mod is coming with this input module, which I spoke a bit earlier. So you can connect, for example, passive temperature sensors with NTZ 10K, 20K, PT 1000, and so on to this, and you can read those values via the bus. So typically this kind of solution is saving your I/O points from your PLC, so you can cut down some cost to have less I/Os at your PLC side and instead use the I/Os on the field device as we have here. And then this DPT mod is also capable of measuring the airflow or the differential pressure, and you can have it also with the auto zero. I would say that the I/O mod is good choice for the air handling units and the OEMs because of these I/O modules. So you can use a cheaper controller. And the DPT mod then is good, this so-called all-around, because it's a combination of airflow and differential pressure measurement, and also available with the auto zero. Then we have this DPT dual mod AHU, which the name says also that it's focused on the air handling unit and the air handling unit producers, because it has two sensors inside, and the first one is actually configured for the airflow measurement, so it has this inbuilt formulas inside to convert the differential pressure to the airflow. And the second sensor is just normal differential pressure, and you can connect it to the filter, for example. And in addition, it has these two I/O points. So basically, by putting two of these devices, you can get 4 pressures, or 2 pressures, and 2 airflows, and 4 temperatures. So that almost covers every measurement for the pressure and the temperature. So as said before, it reduced the amount of the I/O points from the controller side. So you can use cheaper controller, and also it reduced the amount of wiring and the installation cost to make the production more lean. And here is an application example once more about the DPT dual mod. So as said, you can measure the filter, the fan, and 2 temperatures. So let's go then to the second product line we have for the indoor air quality measurements. So first, something I noticed actually just 1 week ago, I was reading this REHVA new guideline for the ventilation suggestions for tackling down the COVID-19 impact, because we have learned that this COVID is transmitted also airborne particles, and then we can also impact how well or not well it transmits by controlling the ventilation. So basic rule is to make sure that the flow rates are higher than normally, and to indicate that, what you can do is basically measure the CO2 levels from the rooms, because that correlates to the fresh air and the flow rates. So I find out that they suggest this kind of indication for the CO2 levels, especially for the schools nowadays, because in Europe, mainly in the Central Europe, there are many school classes that do not have mechanical ventilation. So all they can do to make the air clean is just open the window. But then when to know when is the time to open the window, they need to have some kind of indication of the air quality. And the best way to do that is by using the CO2 indication. And there are certain levels that you need to do some measures. For example, if you go close to 800 and over, you should have some kind of indication that now you have to do something, and what to do is to open the window. But if that doesn't help and the level starts to increase over 1000, then you should have some kind of indication again that now the situation is serious, and what you can do then is just get the people out from the classroom and leave the windows open and just let the air clean. And we have this device, for example, for that purpose. So this is the CDT 2000. It's CO2 and temperature and humidity transmitter for rooms. So the applications can be meeting rooms, and nowadays especially school classes for CO2 level measurement. So basically you can use this CO2 measurement on this kind of rooms that are not always occupied, because then you can use this demand controlled ventilation strategy to save energy and making sure that there is always a decent amount of fresh air inside. So we have this CO2 transmitter for rooms and also for the duct. So with the duct, you can get the CO2 levels from bigger area than just one room. And in the CDT 2000, we have as an option this big display, which is very good for this COVID-19 indication in the school classes, because the display is big touchscreen and you can get this kind of smileys to indicate if the levels are good or not. And then we have also option for the relay output. It's like a simple control when the set point is reached. And we added just maybe 1 month ago this new feature which we called TEP. It comes from the words time extension button. So basically the user can use the touchscreen and push some it's like a clock. You just push it and you can put 1 hour, 2 hour, 4 hour or 8 hours, like this kind of extra boost ventilation. When you press it on, the relay will snap and ask the control device to put more air to the room. And we have 2 different sensors available there. Other one is called ABC Logic. So it has this like a background calibration interval. So it makes sure that the 0 point doesn't drift over the time. So basically the lifetime is more or less 10 years when using this ABC Logic, and it stays that time within the tolerance. And then for this kind of rooms or area that are constantly occupied, like hospitals, we recommend this dual channel sensor, because compared to the ABC Logic needs a certain period of time in 24 hours, and the level needs to be close to 400. But if it doesn't have that moment when the CO2 levels are like a fresh 400 ppms, this 0 point will go wrong. But for those purposes, we have this dual channel sensor available, so that is then not a problem. And here you can see the picture of the duct model for the RHT. So we have the humidity also mounted to rooms or for ducts. Yeah, we have also this local display available for this duct model. And the sensor itself, it doesn't need any periodic calibration. And in the room model, also this applies to the CO2 and the humidity, both versions. We have this kind of simple data logging, which is for the display model, which you can see the last 48-hour data logging. So you can see if something is wrong in your building, what comes to CO2 or humidity or temperature, you can make then some adjustment to your system. Then we have this new indoor air quality sensor that is coming up after a few months. We are working on that one now. And what separates that from the previous is that this will be having more sensors what is sensing the indoor air quality. So in addition to CO2 and humidity and temperature, this one will be having the VOC sensor for the odors, for example. And then what I'm excited about is this new PM 2.5 or 10 sensor module, which is coming on phase 2, which be later on next year. Because this small particle measurement is actually very new, but we know that there is much demand for that. Well, not maybe in Finland because we have so pure fresh air here, but there are many places in the world where you need to know the small particle levels because they can be really dangerous level in some days, in some places. So it's good to know the buildings where you are, that if you need to do some measure for that. So we have also updated this new design for the enclosure to fit different kind of interiors. And it has also this display, and we have made this kind of indoor air quality index, which shows from 1 to 5 the level, is it good or poor, and also this smiley indication is along with this indoor air quality index. So then we have still some more sensors to come up. So this is the passive temperature sensor series. We have those now for air, and here you can see maybe the most commonly used one, the duct sensor. So the applications are the temperature measurement basically from different parts of the air handling unit. For example, supply air. For example, to control the heating coil to maintain the desired supply air temperature. And we have this one for five or six different sensor elements like NHA 10K, 20K, PT 1000, nickel 1000, and this nickel 1000 for Siemens logic. And this duct sensor you can install straight away to the duct. In some cases, you don't need to have the flange, which is sometimes a bit problematic to install because, as you can see from the picture, you have these ears which have the screw holes, so you can screw it directly to the duct. And we have also these detachable terminals for easier commissioning for the wires. Then we have these room sensors. So this is very basic sensor. So for the room temperature measurement, so that you will be having a desired room temperature. And we have optional to implement 2 different thermistors in one unit. So if you don't know if the project is having PT1000 or NTC10K, you can have this with both of those, and based on the building or the system, you can use it either way. And the cover is very easy to open, and you can bring the wires from different sides easily. And this one has also these detachable terminals. And then we have this cable sensor, and the material is silicon, so it can withstand this kind of really a wide scale of different temperatures. So normally they are with PVC, but this one is silicon, so you can use it also with the more demanding applications, such as underfloor heating or some fridge. And because we are from Finland, we wanted to make sure that this is also feasible in the sauna and also in the fume hoods. And typically these cable sensors is good choice for the air handling unit producers, because they can easily put this inside the unit instead of this duct sensor. And then we have this combination of the outside air temperature and the illuminance sensor, which is totally passive. Especially here in the northern countries, we are using this outdoor illuminance to control the outdoor lights, because the length of the day here is varying a lot. For example, now at this time of the year, I cannot hardly see any bright sunshine at all throughout next few months, so no light at all. But in the summertime, it's completely the opposite. There will be bright day and night. So typically these illuminance sensors has been active and needing power supply, but this one it's working with this similar kind of principle as the thermistors. So it's totally passive. So you don't need to bring up the power supply, but instead you can just bring 2 wires for the outdoor temperature and the illuminance to your system. Oh, actually, now that I said a bit wrong, that one is actually the combination of the outdoor illuminance and the temperature. But basically we have also, you can choose between just the temperature for outdoors or the combination. It's up to you. They are basically very similar. And then we have the last one, which are basically the first ones what comes to the products we came up back in 30 years ago. So you can see the liquid column manometer, which was actually the first product that HK produced back in the days, but that product is actually still going strong, and it has been used widely for this kind of simple filter monitoring, because it doesn't need any power supply. All it needs is to add the liquid, and then you can see what's the status of the filter. And then we have this gauge, DPG, which is also very convenient because it's basically maintenance free and good visual differential pressure gauge for many different applications. You can use it for air handling unit to see the filter pressure, or you can use it to monitor the differential pressure between different rooms. For example, in the clean rooms, because you can clearly see the needle from far away, so it's then a good visual check for many different applications. And then we have the differential pressure switch, which you can see below. And it's really simple mechanical switch, typically be used to express when the filters are dirty, to give the alarm to the system. So that's basically it. Or also you can use it as the fan monitoring. So if something happens to the fan and the duct pressure drops, you can set alarm by using this one. So that was all for the products and the HK instruments from now. And I hope you enjoyed the presentation. And now if you have some questions, or if there has become any questions, you are free to ask me or Janes.